We all know f of x is the CDF, right? Now, in certain fields, such as medicine, biostatistics, we would rather want to look at something called a survival function. Now, why do we call it survival? We call it survival because we want to know, well, what are the chances that something would survive past a certain point? We want to find the probability that X would exceed a certain value. Very good example would be, cancer and life expectancy. What are the chances that, say, for instance, you get prostate cancer, that you would live past 10 years since diagnosis, right? If you're an unlucky person, it's just 10 days, right? Stage 4. So in those cases, we want to look at probability of greater than rather than less. So survival function is a function that's commonly used in medicine. The other case would be in industrial engineering. You may think industrial and reliability engineering. Why would it be important there?
It would be like an earthquake, like a bridge surviving an earthquake or something.
Right, bridge surviving an earthquake, probability, certain magnitude and higher. Or you could say, what are the chances, how reliable, say, a camera is? So it's awful. So we want to, how long is it going to last? So we want to find the probability greater than, say, 3 years. So if that probability is quite large, then we have more faith in that device. Does that make sense? So it is used in industrial engineering, reliability stuff, and biostatistics. That said, there is a connection between this and expectation. So expectation of a random variable is x times f of x, but we could also write this as probability of x greater than some dummy variable t dt. Zero to x. Good. So what we're saying is, if you want to find the expectation, we can take the survival function, which is x greater than some value t, integrate it from 0 to x, you would end up getting the expectation. Well, there is another way to write this. I could change the limit from 0 to infinity. Yes. How should I define x greater than t? In other words, t is less than x. I have not picked an individual value, rather a random variable. Going to modify here. This is not equal, the equal shouldn't be here. But that's what we're trying to show. The expectation related to the survival function. So what would integral 0 to x? I'll explain what I is. I didn't go over this. So have we seen I written that way before? No? So I stands for an indicator function. So in this case, when I write I, x greater than t, I intend to say that would equal 1 if x is bigger than t. Otherwise, it will be 0. Correct. So if the value of x is bigger than t, then we will end up getting 1 always. So in this case, if I put in 1 here, what is the integral of 0 to x dt? In other words, t is less than. If x is greater than t, it is the same as saying t is less than x. Correct. So is t less than x according to the integral? Yes or no? Yeah. So this has to be 1 always. So integrals 0 to x, 1 times dt. So that integral will always equal to t cross x. Correct? So I just wrote x in terms of the indicator function.
It's 1, 0, and 1 x. Or
so now I am going to change the uppercase, excuse me, lowercase x to uppercase. Like that. This should have been lowercase too. Right. So if I change to uppercase x, I can write this as 0 to random variable uppercase x, but I don't want to do that because x is random, not a single value. So it can go all the way up to infinity. Do you agree? So I'll put it as infinity, but put a restriction that x has to be greater than t. Good? Do you follow? So in other words, this integral is going to switch on in a sense only if whatever value that you pick for the random variable is bigger than 2. Agreed? So we wrote the random variable this way. Oh, change that to infinity. Because I'm going to take an expectation of this, so that has to be infinity. Okay, so take expectation on both sides. So expectation of x would simply be equal to integral 0 to infinity. That now it becomes lowercase x because we are taking individual values for the random variable. So lowercase x. But this has to be multiplied by something to get the expectation. What should we multiply by? F of x, the density function. So f is simply the PDF. But we can't simply throw in the indicator function. We have to put in the density also. Come again. Doesn't matter, it's a dummy variable, right?
Because you have DC there. You said it doesn't matter what variable you have there, but when you have that, you have a DC there, so it doesn't matter.
So expectation of this would simply be equal to that integral multiplied by f of t. So there has to be two integrals. I messed up, I skipped a step. So we'll do it one step at a time. Expectation, replace x by integral 0 to infinity I x greater than t dt. Replacing the entire random variable by that integral. Yes. And then I need another integral for the expectation. Do we agree?
Since it's the integral from 0 to infinity and little x isn't random, it's little x is a constant, correct?
Yeah, it's a value.
So t is also a constant.
It's a number, guys.
So so that means that integral there would also be a constant, correct?
Oh,
And the expected value of a constant is just a constant.
it's a random variable. So uppercase x. So I'm changing that entire x to be this, but we've got to take this and integrate to get the expectation. So all of that, so you put 0 to infinity, I x greater than t. We're going to evaluate it over the values of x, correct? Because we're trying to find the expectation of this random variable. So anytime we have expectation, I don't want to use x again, so I'm going to use y. If we want to find expectation of y, we would write it as lowercase y multiplied by f of y dy, correct? So going to take xt, x is greater than t, dt, integrated over what values? The x values. So f of x and all dt. Oh, forgot the dxt. Good.
The bracket be to the left of the dt.
Yes. Thank you. Good. Now, what would this equal to? Indicator function, density, I'm integrating everything as long as x is bigger than t.
That's still be big X should be transformed to the left.
Big X. Big X. Because we're going to take different values of x throughout this integral. Easier way. Let's take a bell curve. Right? And that's x. I've got to pick a t. That should be pick a t. How about right there? T. Good. For any value above that, we are going to switch on. The indicator variable is going to become 1. Correct. So it's going to become 1 here, 1 there, 1 there, 1 there, 1 there. Keep on going. So I am going to integrate the function for the random variable x bigger than t, randomly selected from here as long as it is bigger than t. So what am I evaluating when I evaluate that integral? From an infinite standpoint, that's why I'm doing these lines closer and closer. You should see it by now. The area under the curve above t, correct? What is the area under the curve for a continuous distribution?
Probability that x is greater than 2.
In this case, it is a probability that x is bigger than t. Does that make sense? So this integral simply means it's turning on, as long as the value of the random variable x is bigger than t, and you're going to keep on integrating as long as the values are bigger than t. So if you do it in an infinite way, that entire part should reduce to probability of x bigger than t. Do you agree? So that is the integral that's within the square brackets. Get in there, Dennis, give me a second. So that is the integral right here. Area under the curve will be the integral there. So that simply is the probability of the random variable x greater than t and dt. So expectation of x is simply the integral from 0 to infinity. Probability of x greater than t dt. And that's what I got here. So that is the relationship between the expectation of a random variable and the survival function. In other words, you can simply use the CDF to find the expectation, right? Because survival function is related to the CDF. So you can use the CDF to find the expectation directly. Yes?
And that's only for the survival function, or were you trying to generalize that to any continuous?
Yeah, only for a survival function. In other words, g of x has to be 1 minus f of x, and uppercase f has to be a CDF. Otherwise, this is not going to work. Good. Do we follow?
We have an example of the survival function.
We'll do one. the best problem to do a survival function is exponential or gamma. So that's what I'm going to do. That's when I'll do survival function.